Hi children. This is our first video for the grade 7. With the Click Learning, if you have been there for the grade 6 also, you know about me and my video series and the quality of it. This is for the grade 7. So if you are newly joined for grade 7, hi, welcome you all to my channel. Basically this channel, what we are doing is, we are supporting especially the English medium local syllabus of Sri Lanka, right? So initially we have started with IT and this is for grade 7 IT lessons. So we will be using the textbook which is given by the government. Most probably you may have received it free, already bought the book. So this is the online version of it. So this online ebook is easily you can download from the government site. So it's freely available book. So I will be following the book and if you have any questions you can comment. Okay, so this is the first chapter for the grade 7 central processing unit. So you may have some idea what is the central processing unit. At least you may know what is system unit, right? Because CPU or the central processing unit you cannot see it, kind of, because it is located inside the system unit, right? So they have given the computer is like the kitchen of a hotel, and central processing unit is the chef in that. So actually it's like our brain. It's the one who is doing all these processing data in the computer and converting the data into information, right? For example, now chef is the one who will be preparing food, right? So actually the speed of the food preparation depends on the speed of the chef. If chef is very lethargic, he takes time to cook and all, the final output will come with a latency. But if the uh, chef is very fast, definitely the food preparation is also going to be fast and you will get the output quickly. So similar to that, the computer speed directly depend on the speed of the central processing unit. And you may have heard the word dual core, right? So dual core processor means it's like kitchen with two chefs. So if you have two chefs, definitely you can prepare two meals parallel. So it's faster, right? So similar to that, if you have a dual core processor or the CPU, it's actually faster, right? CPU or the central processing unit, these the terms are very important, right? Now CPU, if you heard that word, you should get what it is and what is the what is that central processing unit, right? This can be identified as a digital circuit which processes data according to given instructions. What do you mean by these given instructions? Computer cannot think and do something, right? Always user should give some instructions. Okay, based on these instructions only the data is processing. What computer basically does is, there is data, so the computer will process the data and will create the information, right? We have learned this in grade 6 also. So basically CPU is the one uh, which basically taking the leadership in this, right? So whatever task performed by the computer, in all instances, the central processing unit runs in background. So without the central processing unit, you cannot work in the computer. So most of these tasks are done by the central processing unit. So it's the basic or the main function done by the processor. Processor means CPU, right? Is to execute all the instructions, right? And then gets the data, process the data, and give the relevant information. So most of the people, or most of the you have been seeing the system unit, right? In the laptop, we cannot see this even, right? It's inbuilt to the laptop, kind of. If you have a desktop machine, you may have seen this system unit, right? So inside the system unit, you have motherboard, right? So you may have seen these motherboards if you have seen broken or like damaged computer, sometimes you may have seen the motherboard, right? So inside the motherboard, it's fixed, right? So the central processing unit is inside the motherboard, right? Okay. So let's identify the components of the central processing unit. So in the central processing unit, basically three main components, right? So first thing is ALU, arithmetic and logical unit. Second one is control unit, CU, and the last one is memory registers, right? So arithmetic and logical unit. So all the mathematical and logical functions, right, are performed in this unit, right? So what do you mean by mathematical operations, right? Like addition, adding 2 plus 2, subtraction 5 minus 3, multiplication 2 into 3 is 6, right? And division 8 divided by 2 is 4. So all these mathematical calculations, adding, subtraction, multiplication, and division, all these things are done by the arithmetical and logical unit. So that is the mathematical calculations. And what are the logical operations? Like greater than, 3 is greater than 2. Is it true or false? True. 2 is less than 5. Yes, it's true. So those are logical operations, right? 2 equal to 4. False, right? So these things are considered as logical operations. So both logical operations and mathematical operations are done by the ALU, that means arithmetical and logical unit. Next thing is the control unit, right? So actually control unit is the one which manipulates and control all the hardware to the hardware connected to the computer, right? Like it is controlling the input and output data, ensuring that the data is sent to the right place at the right time, right? And CU is very alert. CU should be staying very alert to all the signals they receive, right? So CU is some kind of a like controlling all the units of the computer. CU, control unit, right? So in here in your book they have given few tasks, right? One thing is controlling input and output data. Second thing is ensuring the data is sent to the right place at the right time, right? Next thing is being alert to the signals, whether they are whether the processing is happening correctly, is there any errors? So that alertness also done by the control unit. So last thing is the memory registers, right? So memory registers temporarily stores the data and instructions that are being used by the central processing unit, right? So this is like a storage, right? So the capacity of the memory registers is very low, right? That means if you consider about hard disks and other portable storage devices like pen drives, CDs, DVDs, and those things, the memory capacity is very low. But remember, registers are very expensive, right? So with compared to the other storage devices, and the data access speed is very high. That is why they are expensive. So memory registers are very expensive, and they have a high speed of data access, but the capacity is very low because we are using lesser capacity for memory registers. The size is also small because it's very expensive, right? Okay. Then we are going to learn about the evolution of central processing unit, right? How it got evolved, right? There, so the computer is not a one night output, right? For the many years, it was evolved, right? So The central processing unit, the generations of it can be divided into four things like first generation, second generation, third generation, and fourth generation. So you should know what happened, basic idea, not the whole history, but you have to basically know if somebody tell first generation of CPU or the computer, it is about vacuum tubes, right? So that is the main technology they used. Okay, so when we consider about the power consumption of the first generation, it's about the time period of 1940 to 1956, long time back. So the power consumption is very high, right? Because and it emitted a lot of heat, these computers. So there should be a separate cooling system to control the heat, and therefore the power consumption of the whole thing, whole system, the cooling system and all, it was power consumption is very high. Okay, and the size of the computer, it's about a room. Right now, you have very tiny laptops, notebooks, and all, but those days that computer is about the size of a room. And execution speed is measured in milliseconds. Okay, now you will think milliseconds, it's faster, right? Nowadays, it's we'll go through and see what's the speed. Then you will understand how slow it was initially. And cost, it was so expensive. The cost is high because the production maintenance, those technologies were not there, and it took so many effort. So the cost is very high, right? So examples are ENIAC, UNIVAC, and EDVAC, right? So these things just remember for the reference. And the second generation of CPU has used transistors. Okay, so power consumptions when compared to the first generation, power consumption is low, but when compared to nowadays computers, still the power consumption is high, and the size of the computer also reduced compared to the first generation. So first generations ones are bigger, then comes the second generation. They are smaller size compared to the first generation computers, and the execution speed increased, right? Because execution speed was measured here in microseconds, right? Earlier it was milliseconds, then it is microseconds. Still, the expensiveness was there, cost is there, but compared to the first generation, it's bit less. So, examples they have given IBM 7030 and CDC 1604. Right? At least remember one example from each generation. Then comes the third generation. Integrated circuits were used as the technology of these CPUs. So power consumption, it compared to the first and second generations, the power consumption is less, size is smaller, execution speed is more because now it is measured in nanoseconds, and cost is also reduced. Okay, so you can see a pattern. I will explain the pattern after I explain the fourth generation as well of these four um, features. Then comes the fourth generation, right? Nowadays computers, right? Duration of the time is like from 1971 to the today, right? So now we are using microprocessors, right? So less power consumption with compared to the other three generations, smaller size, and speed is also high, and we are measuring the speed using MIPS. So these terms are very important. If you see CPU, you should know its central processing unit. If you see CU, you should know its control unit. These terms, at least use a separate book and write these terms in a separate place. So you can quickly refer, at least weekly refer these terms, then you will remember. Okay. So MIPS, million of instructions per second, and picosecond. Okay. We'll go and see what is picosecond. Give me 5 minutes. After 5 minutes, we'll talk about what is picoseconds. You may have heard milliseconds, microseconds, nanoseconds, but may not heard about picoseconds. We'll go and see. So the execution speed is measured using MIPS in microprocessors, and the cost is also less, right? So examples are the modern computers we are using. So here they have given you the relationship, right? Millisecond. To get a millisecond, you have to divide the second by 1,000. If you divide the second by 1,000, you will get milliseconds. That means 1,000 milliseconds are there for a second, right? And 1,000 microseconds will be there for a millisecond. So with compared to the second, it's about 1,000 into 1,000. You have to divide 1 second by 1,000 into 1,000. Okay, understood? If you go with the terms of 10 to the power, first one is millisecond is like that means 10 to the power 3 milliseconds. That means 1,000 milliseconds are equal to 1 second. And about microseconds, 10 to the power 6. 10 to the power 6 milliseconds are equal to 1 second. Nanoseconds means 10 to the power 9 nanoseconds equal to 1 second. Understood? And picosecond means 10 to the power 12. 10 to the power 12 picoseconds is equal to 1 second, right? So you may have understood the relationship now, right? So the speed of the central processing unit, uh, we call that as clock speed also. So if you heard about clock speed in a computer, that means the speed of the central processing unit. That means number of instructions, how many instructions have been executed in a second. So that is how we measure the speed, right? Clock speed. So the unit we use to measure the clock speed is hertz. H is it hertz, right? So in modern computers we use megahertz, gigahertz. Like that speed is more with compared to the previous computers. So we use like this now. See, kilo means always 10 to the power 3. That means 1,000. So 1 kilohertz means 1,000 hertz. Megahertz means 10 to the power 6. Okay, that means 10 to the power 6 million hertz equals to a megahertz. Giga means 10 to the power 9. Okay, so remember, right? You have 1, then 10 to the power 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga. If you count to the other side, 1 is there, 10 to the power minus 3. It is here. Minus 3, it's milli. The 10 to the power minus 6 is micro. 10 to the power minus 9 is nano. 10 to the power minus 12 is pico. So you can see the chart of the relationship now in the screen, right? So did you understand how it works? Right? These are mathematical terms. These are not IT stuff. This is mathematical terms. Okay, so that is the end of the chapter. Very small chapter, right? So in this chapter we learn about CPU. It's the brain of the computer. Right? Don't write CPU is the chef of the hotel, right? Because you have to explain it. What is CPU? So central processing unit. It's like the brain of the computer, and it's located inside the system unit, like attached to the motherboard, right? So in there are basically two units. Actually, there were three units. ALU, CU, and memory register. So what ALU does is all the mathematical and logical operations. CU will control all the hardware and all the devices, right? It controls all the operations of the computer. And then comes the memory registers. It's like the temporary memory store, right? Very expensive, less capacity, but high speed. Okay. And so evolution of the CPU, there were basically four generations: first generation, second generation, third generation, and fourth generation. So you should know what are the technologies they have used. So vacuum tubes, transistors, integrated circuits, microprocessors. So over the evolution, the size of the computer has been reduced. Okay, the speed of the computer has been increased, right? And this expensiveness has been reduced, the cost has been reduced, the computers has become more cheaper. Okay. And the final thing is the power consumption. So it has been reduced, right? So that's why the computers are becoming a bit cheaper and cheaper, and the speed is high. So that is because of the evolvement of the CPU. Understood? So yeah, that's the end of the chapter 1 for grade 7. So if you haven't subscribed my channel, ICT Learning channel, this is an online e-learning channel you can go through. So please subscribe it. Right, if you have already subscribed, press that bell icon so all the notifications will you will receive, because when I upload a new video, you will get the notification. And if you have any comments and all, please do comment. I will help if you have questions and all. And if you, some people add blessings and thank you messages, thank you very much. It like really it make me happy and like appreciating my work. Thank you very much for that. And you can like or dislike my video so I can improve myself also. So thank you very much. Let's meet with the chapter 2.